Okay, in this video I'm going to do a bandwidth problem, and in this problem we're given a composite signal composed of 5 other signals with frequencies f1, 2, 3, 4, and f5, and these are ranging from 12.20 gigahertz to 13.2 gigahertz. What is the total bandwidth occupied by this composite signal, and what is the spacing of these signals? Express your answer in units of megahertz. Really the easiest way to do this problem is to first draw a picture to visualize this. And I practiced it on a piece of paper a little bit ago so that I could draw it nicely. If this is the frequency axis here, the horizontal axis is frequency. Let me straighten that out. Then I'm going to start at 12.0 and I'm going to go to 13.0. Make sure you can see it. And I'm going to divide 12 up into 10 increments. So I need 1, 2, 3, 4, 1, 2, 3, 4. They're not even perfectly evenly spaced. Sorry. 1, 2, 3, 4, and then 5, 13.5. So here's 12.5. And I'm going to draw these in as little spikes because we have 5 frequencies. One is at 12.2, and so that one's going to go right here. The other one is at 12.45, so that's in between 12.4 and 12.5. And I'm sorry my spacings are not even, but I'll still be able to draw. Then I go to 12.7, which is 2 lines past the 12.5. And finally, 12.95 between 12.9 and 13.0. And finally, 13.2 here. So you can see we've got a signal created out of 5 sine waves. And our total bandwidth is going to be the difference between the highest and the lowest frequency here. And I'll say F high is F5, which is 13.2 gigahertz, and F low is F1, which is 12.2 gigahertz. Hey, that makes it easy. The bandwidth is F high minus F low. Notice that I'm following my problem solving procedures here. I'm writing down the variable's name and then its value with units. I'm writing down all the variables' names and values with units. Then I write down the equation, and only then do I plug in the numbers. And so I can go 13.2 minus 12.2 gigahertz, and this is 1.0 gigahertz. Okay, and you can see that the spacing here is from 0.2 to 12.45, so that's a 0.25 spacing, and I'll call delta the spacing. And it turns out that they are evenly spaced. You can kind of see that from the diagram here. They look evenly spaced. And I think that if I go F2 minus F1, I'm going to get 0.25. If I add 0.25 to the 12.45 again, I'll get 12.6 and then 12.7. Yep. And add 0.25 to 25 to 70, I get 95, and add 25 to 95, and I get 20, bringing it over to 13.2. So we can write the spacing as either the difference between F1 and F2, F3 minus F2, F4 minus F3. Let me straighten that out. Minus F3 or F5 minus F4. They all give me the same spacing, which is 0.25 gigahertz. But they want it in megahertz. And so this is 0.250 gigahertz. And so we can see our answer there in megahertz, 250 megahertz. because 1 megahertz is 1/1000th of a gigahertz. And so if I write my gigahertz value with 3 decimal places, those 3 values there become the megahertz value. And so this is how you do this problem. I think it's very important to draw this picture and get a visualization for it, and also practice your problem solving technique of writing out the variables, plugging into the equation. Try not to just do a very quick, 13.2 minus 12.2 is 1 gigahertz. You really need to show your work. Okay, hope this helps.